Good morning, good afternoon, good evening, wherever you are, and welcome back to another episode of Electric Air Mobility. My name is Nicholas Zard. I am the founder and CEO of Electric Air Mobility LLC. And what we do is basically we provide vertiport infrastructure and energy solutions, a whole ecosystem around that. So on electricairmobility.news, we talk about everything around advanced air mobility, specifically electric air mobility. But one of the things that kind of dawned on me is, without explaining what mobility is, what transportation has become, and how everything has evolved over millennia, it might have been a good idea to also start with this series I just finished writing today. It's a three-part series on the evolution of mobility and how we went from two legs to horses to eventually electric dreams, going through a steam engine phase. So in this very first part, I'm talking about how we originally, as humans, went from walking to observing these horses that could, well, for one thing, run much faster than the bipeds that we are, but could also theoretically at least carry heavier loads for a long, long time, right? So someone, a bunch of people, who knows, eventually thought, if I could just climb on top of that horse on his back, I can go much further and much faster, and I can still carry a lot more things. After all, a horse is much bulkier, much more muscle mass than I am as a human being. And so they did. And that was fine for millennia, right? Eventually, somebody also figured out that if you cut a sphere into slices, those slices made for perfect wheels. And I don't know how they got to A, do that, and B, put that on a platform and invent chariots, but somehow they figured out how to do not only that, but use a horse to carry all of this. Now in this series, I wanted to write something tongue-in-cheek, because if you know me, you know that I usually have a pretty, I was going to say a good sense of humor, but that's debatable, right? You might like it, you might not like it, but I try to indulge in a little bit of humor because these days we need more humor than anything. So I also make references to UFOs and aliens and everything because, quite frankly, I actually really enjoy the conspiracy theories. Not that I believe or not in them, but just for the mental gymnastics of it. So yes, I do say once in a while that maybe aliens whispered in the ears of these people to domesticate a horse, to make wheels, and much more, as we'll find out. So for hundreds of years, and if not millennia, for thousands of years, we were all fine just having horses and carriages and chariots and things like that. And that was fine to go over greater distances, carrying much bigger loads and everything. But humans are known as not leaving things alone very well. And one thing that human decided to do at some point is to figure out an even better way to replace horses. Now, that wasn't easy. And the way that I can kind of see it was in ancient Greece, which was extremely undeveloped at that time. They went to the center of the world where all the technologies, the philosophies, the religions were being invented, were sort of coming together. And that was Egypt. All around from Beirut down to Egypt was really the hotbed of all the greatest scholars, all the greatest sciences, all the greatest technologies went there. And that's why to this day we still find coins, Celtic coins, Druid Celtic coins with Buddha-like figures sitting down in what we now know as being yoga position. So it's really fascinating to see the spread. But one thing that is really well known is that around that time, Egypt really had attracted scholars from all over the world. And I really do mean by all four corners of the world, even things that our modern archaeologists cannot explain. Things from South America, for instance. How did they manage to go above and beyond all that? So I know this goes way above the scope of advanced air mobility, but it's important to understand that mobility is not just something we think of. It's not something we just woke up with and decided to, hey, I'm going to fly with batteries today. There was a huge millions of, well, thousands of years, maybe millions, who knows, right? Remember aliens? But maybe it really had all of that velocity building up behind, from walking to being on a horse to inventing the wheel. And to what happens next is these guys go down, these ancient Grecians go down to Egypt, and they find out about all sorts of sciences and technologies and theories and well, all kinds of things basically. But one of the things that they bring back is steam. Maybe not directly from the Egyptians, but they decide to boil water on somewhere back in Greece, and notice that steam applies a lot of pressure, and they have to put a valve so that the container does not explode. Well, there you go. That's power. And this was the earliest, crudest form of a steam engine prototype. But it would take, again, hundreds and thousands of years before somebody, somewhere along the line, more bright souls decided to go, how can we use this to move multi-ton metal trains down the road? So before the trains were invented, the original trains were really wooden wheels on wooden rails. And the reason is less friction, more efficiency. Now, if you look at cars today, it's probably about the worst efficiency mobility platform you can have. Rubber wheels on tar, opposing piston engine with internal combustion technology. Whoa, phew, not very efficient. And I'll give you some numbers later. But the steam engine is still to this day is still seen as the most energy dense motor on this planet, meaning within a given space of weight and volume, it can move a lot. It can develop a lot of power. And if you take into consideration steam trains, we're able to haul 900 tons, maybe sometimes 1,000 tons and more at speeds of up to 50, 60, 70 miles per hour, depending on a lot of different things. But that also happened on cars. So when we moved away, the steam engine basically replaced horses and carriages and things like that. And it moved the horses out of the equation, thankfully for them, kind of retiring them to the stables to just go horseback riding, but also to put a steam engine on the cars. But the repercussions are absolutely mind-blowing. If you've been to San Francisco, you know that these hills are very steep. And if you know or might not know, but it was horses that used to bring the trolleys up and then down. That was a lot of load. And somebody felt really bad for these horses, changed all of that with a system of pulleys and cables, steam-driven at first. So when it comes to these steam cars, I've been very fortunate. I got to ride on a steam serpolet or serpolette, whatever you want to call it, which was one of the earliest, last 19th century steam cars. And I think it was the first one to reach about 60 kilometers per hour, which is, pretty amazing. What is it, about 45, 50 miles per hour? And it was incredible because of two things. First of all, the copper wiring of that car was almost hundreds of yards. It was incredible. I don't remember exactly how many yards, but it was long, and it took hours to bring up to steam. But you were sitting way high up above the ground. These were a step away from chariots. So to know that these guys were driving up to 60 kilometers per hour in Nice, my hometown, in the late 1890s was absolutely fantastic. So I left a link in there. You should go see it. It's pretty incredible. But this also meant that the steam power eventually not only replaced horses, but it became the railroad really probably popularized and really pushed the evolution of steam to its ultimate point. And it's not, it shouldn't be too surprising to know that we had steam locomotives run up until the 70s. And I know in Europe until the mid 70s, and in the US even later. Another thing that I also and there's so many bifurcations to be made here, but in the 1930s, something huge happened. at least when it comes to railroads. And we'll jump back again a little bit after that to talk about automotive. But when it comes to railroads in the 1930s, and this is a number I get from the French railroad system, the SNCF, they realized that one electric motive replaced 3 steam locomotives, both in terms of energy, so it could haul more, longer, faster, and without stopping to refuel with water and dirty coal. So it also meant that you could have basically one person driving an electric locomotive and not 2, sometimes 3 people for a steam train. Not only that, but the energy was much, much less. In other words, one electric locomotive replaced 3 steam locomotives. And there's also something else that's pretty amazing about the electric motor, and we'll segue back into automotives. But if you think of the difference between a steam engine, a gasoline engine, and an electric engine, when it comes to locomotives, a gasoline engine, you have to shove a lot of things into it. You have to have the right mixture of air versus fuel ratio. You need to have, most often time, turbos, compressors, and then you have this very small bandwidth of somewhat efficiency, right? But when it comes to the electric motor, it's the opposite. It's 100% torque as soon as it spins. So we have this paradigm shift where we have to cool things off with an electric motor, or else it would shred electric locomotives apart and the walls of tires apart. Another great article to be made is to talk to Michelin about this. So when you look at how an electric locomotive operates, it has little shuntings that you do. In other words, you don't just take the direct electricity from the catenary that goes through the pantographs right down to the electric motors, because they would just spin or just whatever, shred it apart. You have to break it down in steps. And in other words, if you have, like in Europe, 25,000 AC voltage up there, you have to bring it down to maybe sometimes even like 700 volts, and then bring it up through lots of little steps like that, incremental steps. And you go through a series of series and parallel modes of using the electric motors, when finally at full speed, they are running in parallel, all of them. It's pretty fascinating when you look at electric locomotive technology. And I was a big fan, and still is to a certain extent, because it helped me understand electric vehicles, electric cars, and now electric air mobility, strangely enough. Now we're going to step back about 30, 40 years before electric locomotives happened. And by the way, the first hybrid vehicle or hybrid locomotive in the world was GE in the 1930s, that came up with, guess what? Diesel engine, made it to a generator, feeding electricity to the electric motors inside of the bogies on the axles. There you go. Very old technology, but it's finally coming to maturation. So one of the things that I do talk about in here is that some of you might know that the first electric cars were, I'm not going to tell you, because guess what? That's part 2. I just wanted to give you a little bit of a tantalizing look as to what happened after, and which is something I'll go into the second part of this. Of course, I got way excited and I started slipping into the second part, because again, the whole idea of this 3-part series is to show you the evolution of mobility, how we didn't just wake up and go, well, gee whiz, I'm going to take an electric motors and heavy batteries into the sky. Anyway, watch for part 2. I'm pretty excited to do this, and I'm excited to have a little bit of sense of humor. Sometimes it's needed. I think most of the time it's needed, actually. And we hope you enjoy this. We hope you will leave a comment, tell us what you think. And please share, and subscribe to this YouTube video. And hopefully this time I'm going to remember to put the link back to the article. I forgot. I've been forgetting all the time. And yeah, one of these days I'm going to go to my Patreon website and finish the work I started doing. But in the meantime, hope you've enjoyed this. My name is Nicholas Zart. I'm the founder of Electric Air Mobility, LLC, and I'm excited to do these videos and hope you enjoy them as much as I do.